Assalamualaikum dear friends, you are watching Study with Sheraz, and in today's lecture we are going to talk about the absorption spectrum. Basically this is a very important term that is used in the spectroscopy, and the absorption spectrum is one of the core object of interest during the spectroscopic techniques. Basically it's the result of all the exercise of spectroscopy. Basically the word spectrum, just like the narrow spectrum, broad spectrum. So spectrum is a word which shows the range. So if we talk about the absorption spectrum, so this is a diagrammatic or the graphical representation of the range of absorptions by a molecule. Because whenever a molecule is irradiated with electromagnetic radiations, it may absorb some radiations to the higher extent and some radiations to the lesser extents and some radiations not at all. Because in the previous lecture we studied that every molecule has unique type of the molecular energy levels, and only that radiations are absorbed which exactly match the energy gap between these radiations. If you have not watched that lecture of the molecular energy levels, so that lecture is provided at the end screen and the link is given in the description section. So first of all, we are going to define that what is an absorption spectrum. So it's the plot of absorbance or transmittance versus wavelength, lambda, frequency, nu, or the wave number. Basically it's a graph that is plotted between two variables. The one is the absorbance or transmittance. Absorbance is basically the extent to which the radiations have been absorbed, and transmittance is the extent to which radiations have passed from the solution unaffected. Just like we have this sample and we are radiating sample with a large number of radiations. Some of the radiations would be absorbed and the other would be passed from this solution unaffected. So those radiations which have been absorbed, just like this one, is not present here, so it's the absorption of the solution, and those radiations which have been passed unaffected show the transmittance. So in the absorption spectrum, the one variable is the absorbance or transmittance. It may be the absorption in the solution or it may be the transmitted radiations, and the second variable is the wavelength or the frequency or the wave number. It shows that the radiations that have been absorbed, if the spectrum is recorded in the absorbance mode, it would show that at which wavelength, at which frequency, or at which wave number the absorption of radiation has occurred. And if it's plotted in the transmittance mode, then it would show that at which wavelength or any other factor the radiations have been transmitted and at which wavelength they have been transmitted not. So basically this is the graph. This is an absorption spectrum which is given as an example. So it is having two axes. On x-axis there is the wavelength and on y-axis there is the absorbance. So this graph is plotted, or this spectrum is plotted in the absorbance mode. So basically, as you people know that while plotting a graph, we have two variables. One is dependent variable and the other is the independent variable. So independent variables are always plotted on the x-axis. Independent variables are always taken on the x-axis. Wavelength is independent variable, so it has been taken at the x-axis. Absorbance or transmittance is the dependent variable, so absorbance and transmittance is always taken at the y-axis. So this plot is showing that here are the various values of the wavelength and here are the various values of the absorbance. So while examining our spectrum, we would look here. The most highest peak is recorded. The peak having the highest height shows that highest absorption has occurred at this point. So we trace back this point on both axes, x and y. If we trace it on the x-axis, so it's showing that at wavelength of almost 330 nanometer, maximum absorption has occurred, because the height of the peak shows that this is the point where maximum absorption has occurred. So at the wavelength of 330 nanometer, maximum absorption has occurred. And on this side, it's showing that how much absorbance has occurred. This is the value that at which wavelength the absorption has occurred. Absorption has also occurred at this point. So there are many absorptions, as I mentioned earlier, there are many absorptions, many energy levels, but we are most concerned with the most highest peak in the spectrum. So this is the highest peak, so it's the lambda max. So this is the point where maximum absorption has occurred. And on this axis, here is the absorbance, extent of absorption. So it shows that maximum absorbance has occurred at this wavelength. Here is also the absorbance, So many absorbances are also present, but we are concerned with the most highest value. So what are the information that we can interpret from the absorption spectrum? So there are two factors that are interpreted from an absorption spectrum, as I mentioned, wavelength and the maximum absorption. So first one is the wavelength, lambda max. It shows the wavelength at which maximum absorption occurs. It's used for qualitative analysis. So basically, lambda max or the wavelength is showing that at which wavelength the maximum absorption has occurred, and it gives information about the structural features within the molecule. That's why it is used for the qualitative analysis. And the second factor is the intensity. So first of all, what is intensity? Extent of absorption at a specific wavelength is called the intensity. This is the axis of absorbance. Here the values of absorbance are plotted, but at which point the maximum absorption has occurred is called the intensity. So this is the intensity of this peak. So intensity of peak means the extent of absorption, how much the absorption has occurred. It gives number of molecules that absorb radiations of certain wavelength. So basically, the intensity of the absorption shows that how many radiations have been absorbed, and the number of radiations is related to the number of molecules absorbing. So intensity can give us information about the number of absorbing molecules. So as it's giving us the number, so it's used for the quantitative analysis. So we can have both quantitative as well as qualitative information or data from the absorption spectrum. So this was all about the absorption spectrum and the interpretation of the absorption spectrum. So if you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Till then, Allah Hafiz.